Hello everyone. Today I'm going to do a tutorial of how to do coastal flooding analysis using ArcGIS. It's a simplified coastal flooding analysis without using any numeric modelings. So when we do the real modelings, when we do the real flooding analysis, we could use the Xserc Delft 3D, but that takes a long time, a lot of resources to do that. So if you want to do this in a few days, a quick project, you can do it this way. So the first thing is to find the place of interest. So I found the one place in California near the Long Beach. It's a beautiful area. I've been here before once. The first thing is to download the DEM, the elevation data. So the place I will go is USGS, the DNM download. You want to click the elevation. So it has all the resolutions. 1 meter, this is 1/3 arc-second, which is 10 meters, and 1 net is 3 meters. So in theory, you want to use the 1 meter one if they have the coverage here. But just for the reference, I just like to download it quickly. I just use here. Click the extend and draw a box here and search product. It will show you what is the product here. So it has the download link. I have already downloaded to save time, and just make sure that you look at the metadata because this give you all the things here, all the references. So it has the geographic coordinates. It has the North American datum of 83. The vertical reference is nav 88, and the vertical unit is all vertical units are in meters. So it has the vertical units in nav 88 and in meters. That's very important. Just keep this one printed out and save it in the folder. You need it anyway. Just make sure that you get the unit correct. That's very important. Download this one. And what you want to do is just open GIS. Open my GIS here. Open the GIS. So the coastal flooding may come from different resources. Like for example, the things we know now is the storm surge or sea level rise or tsunami. So you want to, you can do any of them or just combinations of them. So this is GIS. Let me open the DEM here. Change it. So this is the way I work here. So this place, so for example, this place is a place of interest. Oh, sorry. So the first thing I would do is to create use a part of this DEM because it's too large. So what you can do is create a polygon. It's called target area. Make sure that this is the same coordinate system with the DEM here. So you want to create a target area. The way to do it is this one. Click this one. So maybe I don't know. This area. Maybe this area. Stop. Save it. Click. So now we have our target area. So this is our target area. We can just change the view of it. We can remove this one. So we don't need this one as well. Just remove it. Make it clean. The second thing is to do is we need to find out what the elevation, what kind of flooding level we need. So the easiest way is to, if we want to find it in the coastal flooding from storm surge, from hurricanes, there are a few ways you can do it. The first is you want to look at here. So this is the FEMA, the National Flood Header layer. You want to open this NFHL viewer. So this gives you the area, like how the area look like, what is the flood insurance report look like, what is the reference number. So I think it's here, right? Yep, it is here. I think you should have the transect. Let me just double check here. Gave them a few seconds. You could have the transect here. So this is the flood insurance report number. It should. But anyway, this should give you no. I'm zooming in to see if they can give me some data here. Yeah, just sometimes give you, I don't know what happened here, but it should give you some transect number. But if you cannot find it, just find it here, the flood map products from FEMA. Click here, access all, and click the region you want to know. This is California. I think it's the which county? I think it's Los Angeles County and city of Long Beach. Because I just looked at it before. So to look at Transect, you can download the product here. So this gave you the GIS files, all the Transect informations, but there's something wrong with FEMA here. So what you can do is just look at the flood insurance report. It's either 2 or 3. They give you all the Transect. You just roll down. So you look at the Transect. No, didn't show up here. So if you look at Transect here, so this is the place of interest. So we are looking at Transect 121 or 120, 119. You can find the values here. 120, 121, 119. They give you like 100-year flood insurance. They're very different. But we'll just use one value here. So this is in feet. I believe this is NAV 88. Yes, NAV 88 feet. Just keep in mind that just all the references and the unit matters. Say we use this value, and we'll make clear that this is NAV 83. Excuse me. I want to make it clear that this is the still water elevation. This is does not have wave inside. So, which is good for our analysis. You want to use the still water elevations. 2 meter. So it's 3.5 meters. So we want to use this value, 3.5 meters for analysis. So the next step is to do the analysis. First thing is 4 steps. First step is to use the contour spatial analysis input. I organized my folder using the 4 steps. You can do it this way. It's just easier to organize it. Contour 100-year still water. Just contour 100-year. Interval just give you a large value here, and then 3.5 meters. So the elevation is in meter with a NAV 88 as a reference, and we want to use here as meter as well. So it's doing the analysis. You have this value here. So this is high elevation areas. If I click on here, it's high elevation areas. So this area should not be get inundated. Each time you have different areas. So what you want to do is edit this layer. So just look at the areas that will get inundated. So I think this inside will not get inundated. Let me make sure that I look at the elevation here. So it's high elevation. Yep. And you want to look at here. So you need to do some manual work here. So this is all the way to here. Okay, I got it. So this is also high elevation areas. Okay, what here? Yeah, it is high elevation areas. So what you want to do is connect this. I'll explain why later. So you want to connect the boundaries here. So this is a little bit complicated, but I think it's a good example here. Let's use this one to connect. This is this one. And this one connect with this one. Let me think. Man, yeah. So it should connect this one. Okay. And you want to combine them together. So make sure that you combine everything together. And this one you combine. Okay, I think it's all connected. So we have one polygon here. So what you are going to do next is stop editing and save it. The next step is to use it's called feature to polygon. You want to use this feature to polygon and see where's in this. You give you a lot of polygons here. If you look at here, add field, yeah. So yeah, I think the project didn't work here. So just change this to 2. Oh, sorry. so you cannot calculate the area. It's because you have to change the projections. Right now we're in the at the latitude and longitude, and you cannot do here, so you just need to project it. So make sure that I don't have this. Change the polygon. Project system. Just use a projected system. State plan. In meters here, just one in California. Just one. Yep. Okay. So right now I have one that has the California projection system. Right now, then I can just add one. I can have a field here. Calculate geometry. Calculate area here. The reason why you want to calculate area is you want to delete those areas that is small areas. So you want to edit the polygon, reproject, and delete selected. And I think it's yep. So in this way, you have those areas deleted. So those areas are the areas that should not be getting deleted. For example, so our target elevation is 3.5 meters. So we need to double check that this is higher than 3.5 meters. Yeah. Yeah. So it's all visible layers. So let's just zoom in. So if the is boundary, so this is lower than 3.5 meters. This is higher than 3.5 meters. So inside the, so these are the inside the polygon, the large polygon here. We only have one polygon. That's why I want to connect all the boundaries together. Inside the polygons, so these areas are all inundated by floodings. So we need to calculate the so we need to calculate the flooding values because the elevation could be high and low. Just make sure I stop editing, save it. The next one you need to use is extract by mask. Input raster. Output raster should the polygon 100-year reprint. So just save a so we have a new DEM here. This is the areas of flooding. And what you want to do is to calculate the real flooding in this area. Let's do it by raster calculation. What you want to use is the DEM 100-year minus 3.5 meters. So that will, oh, excuse me. It should be times -1 plus 3.5 meters. And this should be the values you want to see your flooding. Let me think about it. Is that correct? It's two. Yeah, that should be correct. Just output the raster. Yep. Let's see. And this is your flooding areas. So let's use a different to show it better. So this is all the floodings you will have in this area. Those blanks, just add a base map here. was very slow. Why is it slow? Anyway, so the map should be ready to go. So this is the map that is. I want to just double check. Why I just cannot click on anything? Okay, it is finally done. Just some hardware issues here. So I'm changing the display transparency. This shows that, okay, so this area is fine with the current flooding. This area is fine, but this area seems to be have troubles with floodings, including these areas, all the houses here, but this area is fine. Okay, this is like basically the very fundamental way of, this is a very easy way of doing coastal flooding analysis, but from what I experienced in the industry, this is pretty useful. So you can just look at the values here. So it's topmost layer. So you just look at here. So this shows that flooding of 1.2 meters, show flooding of 1.6 meters, this 1.3, and this is water area, so it's higher elevation. So this is less than 1 meters, this is larger than 2 meters. So you can get the floodings of any area, and plus you can add the local sea level rise onto it and get another flooding map, and or you can just add the tsunami map using the same method. Hope this will help you in your research or in your work. Thank you.